So today we're looking at solving, and really the next 3 weeks worth of this unit, this is the second half of Unit 4, is all about solving. And so we're starting here by solving this system, which actually is something that we could have done a while ago, but having just finished it, had a long weekend, it bears having a little bit of review. Now the first thing to point out is that we cannot do this, at least yet, algebraically. Because in order to do it algebraically, we'd substitute what y equals in for y in the other equation. So we'd have 10 equals 1/2 x squared minus 4x. And while it is theoretically possible to solve something like this, we don't have the tools yet to do it. And so we need some other way to do it, and this is why I had you set up some graphing grids. Because we can't solve this system by graphing it. Because we have 2 equations, and we can graph each of those 2 equations. Now for this first equation, notice the first equation, it's a quadratic. So this is going right back directly to the stuff you were doing right before the weekend, the stuff that we just tested on. Yes, you will need to still know all of those things, the graphing and the factoring. It's all going to be coming up still in this unit.
Damn.
So to start with, the graphing. We're going to be graphing this quadratic. Notice right now it's in standard form. Now you might be wondering, what about the number on the end? There is no number on the end. That's right, it's just a 0 down for our c value. But I can still graph it. Now what do I use in order to be able to graph this? There's a little formula. What is that one? Yep. It is the x equals negative b over 2a. Yes, you still need to know it. All right, so we can go ahead and plug that in for this one. In this case, what is my b value?
4.
Negative 4, yep. And that's going to be over 2 times a. What's my a value here?
1/2.
Yep, 1/2. All right, so go ahead and figure out what your x value is, and once you have that, please then go ahead and find your y. So you should have found that x equals 4, because the 2 times 1/2 on the bottom is 1. All right, so then we plug that x value back in to find our y coordinate. And so we find our y coordinate here is at -8. So my vertex then is going to be at 4, -8. We plot that point. All right, we now graph from there, right? But in this case, I'm not going to be going over 1 and up 1. I'm going to go over 1 and up how far?
1/2.
Yep, 1/2. Because we have that 1/2 multiplied out front of the x squared there. And so that means we're only going to go up half as far. So we do that on both sides. Then next up, we normally go over 2 and up 4. In this case, then I'm going to go over 2 and up 2. Half as far, so half of 4 is 2. So it's over 2, up 2. And of course, this is a familiar kind of pattern. We've done this sort of thing in the past. So go ahead and just finish plotting those points out from there. And then once I plot the points for my quadratic, I now need to think about, okay, what's the graph of the y equals 10 going to look like? So for y equals 10, what is the graph of y equals 10? Yeah, a lot of people at first think that it would be this. It'd be starting at 10, but it would have a slope of 1. But that is actually x plus 10. Just y equals 10, yes, is a horizontal line up at 10, because those are all of the points that have a y coordinate of 10. And so we just draw in a horizontal line up there at 10. And then this is our graph for solving our system. And so now that I have my graph, I can solve it, right? The solutions, remember, are where my 2 graphs intersect each other. And so I have 1 point here, and I have 1 point here. In this case, we're just going to give the coordinates of those 2 points. So for instance, that first one's at -2, 10, and then the second one's at 10, 10. And with that, we are done. This is what we're trying to figure out of this problem. All right, now again, we're about solving today. So this is the next one that we're going to be solving. And right now, this thing looks pretty crazy. Because if we're going to try to solve this as it's given, we're going to have a little bit of trouble here. This is really a very complex equation to try to solve, even algebraically. And yet, we can still do it with the tools we have by using graphing. So this is solvable by graphing it. It's just a matter of seeing how. Because, of course, right now what you're looking at is you're looking at one equation, which we cannot just graph this one equation. However, it is still solvable by graphing because, like, if I were solving an equation, I could start where I had that set equal to that, because both of them maybe started off as their own little equation, where I might have had y equals this absolute value of x plus 5 minus 3. And the other equation could have just been y equals x squared minus 2x minus 8. If I want to know where these two equations, where these two sides here are equal to each other, I could actually graph them as two separate equations by putting this y equals into them. And once I've done that, that then makes it something we can solve by graphing. So basically, I throw the y equals into each in order to make them graphable, and now we can graph them. So write it down as the two separate equations now. Make sure you include the original as well, though, so you remember how we dealt with it. And then graph both of those equations, please. So for like that first equation, as you're going and making the graph, you first notice its absolute value, so I hope you're immediately thinking V-shaped graph. And then the plus 5 on the inside, always goes to the left, and the minus 3 at the end, that's going to go down. So I put my first point left 5 and down 3. And then I draw my V. Notice there's no number out front of the absolute value here, so there's no stretch. So it's just going to be going over 1 and up 1 on both sides. Draw that graph in. Yes, use a straight edge. Precision is going to matter a lot on these graphs. If you get a little sloppy, your answers are going to be way off. And then be graphing the second one. Right now, for graphing the second one, it is a quadratic given to you in standard form, and so yes, you still have to use the same formula in order to be able to do that. Now when we do that, we then plug in the -2 for b, the 1 for a, solve it through. You should find here that x equals 1. And then once you know that x equals 1, you plug that back in. And then now that we plug that back in, we find out that y equals -9. And so now we can make our graph because it's going to start over at 1, -9. And notice there's no vertical stretch or compression in this case. So it's just going to be over 1 and up 1. But of course it doesn't keep doing that because this is a parabola, not a V shape. And so then it's over 2 and up 4. And then over 3 and up 9. And notice there I just found an intersection point. And then it's over 4 and up 16, which also gives us another point of intersection. So there's really 2 points again that I'm looking for. I'm looking to see where my two graphs cross. I care about those two. Now in this case, it can be very tempting to then say that my answers are going to be -2, 0, and at 5, 7. But that's a little bit awkward to talk about in this particular case. Because remember what we're solving here. Our original equation was this up here. Notice that original equation didn't have the y's in it. The y's only come from this intermediate step that we put in. The only reason why the y's exist is because we put them in there in order to be able to make a graph, so that we could see where they intersected. But since y is not actually part of the original equation, it wouldn't make sense to give the y values as part of our answer. So when it comes to giving our solution here, because my original equation just has x in it, my answer just has the x in it. I just list out what the x values are in that sort of a case. And so this one then is done. X equals -2 and 5. You now have seen a method on how to go about actually solving an equation set up like this. So write it down and please solve it. Now, of course, we're solving these by being able to graph them. And remember, I can split this one equation up into two, because as it is, I couldn't graph just that, because there's only x in it. So I create the two equations with y in them so that I can then see where they actually are going to cross. All right, so for working this one through to make our graphs, for the first one, our quadratic, we got to find the vertex first, so we do x equals negative b over 2a, and we end up with an x coordinate of negative 2. Then we plug that back in to find our y coordinate, so I plug the negative 2 back in there, and end up getting a y coordinate of negative 9. So the first thing I'm going to do is plot that point at negative 2, negative 9. Then from there, it's a quadratic. And so I'm going to be going over 1 up 1 on both sides, then over 2 and up 4 on both sides, then over 3 and up 9 on both sides. And just to go ahead and finish it out, yes, we will go over 4 and up 16 as well. All right, then once we have those points, we can then worry about graphing the y equals 0. It's just y equals a number, so again, that's just a horizontal line. This one going through 0. And so having done that, we can now see where our two solutions are going to be. So I've got one here, and I've got one here.
Why wouldn't it just be?
And so we give our solutions here. Notice all we need to do is include the x's. Heck, we already know what the y value is. The y values are all going to be 0 anyway. But our x's are negative 5 and 1. And so that's our final solution then, is that x equals negative 5 and 1. So our last one that we're going to be solving here, yes, by graphing, is this one. But if we're going to make a graph of this equation, how do I do it? What's the very first thing I need to do in order to be able to graph this? Yep, we want to put this into standard form in order to be able to graph it, because once it's in standard form, then I can go and find the vertex. So that means multiply it all out. Multiply everything in the first parenthesis by everything in the second parenthesis. And when you multiply all that out, you should get x squared plus 8x plus 12 equals 0, and then we split it up into the two separate equations. Now we can go ahead and graph them. And so your vertex of your quadratic, when you do x equals negative b over 2a, you should be getting a vertex of negative 4, negative 4. And then we make our graph of our quadratic from there. Then we graph y equals 0. Again, notice y equals 0, there's no x in it, so it's just a horizontal line through 0. And then we solve. In this case, do I need to worry about including the y values? No, because again, my original equation up here did not have a y value in it. It only had the x's in it, so my answer will just be the x's as well. So in this case, we get x equals negative 6 and negative 2. Now, the big question coming out of this. How could we have solved this without even having to make the graph? Because now that we've found this solution, looking at our original equation and our solutions, we should be able to see a connection there so we don't have to keep making all of these graphs. Yeah, notice the numbers up in the factored form, like the 6 matches up with the negative 6, and the 2 matches up with the negative 2, but they are opposite. So why would that be? Why would that work that way? Well, it's all about making this whole equation equal 0, right? Notice what happens if I take like the negative 6 and plug it back in, like I was going to check my answer here. If I plug that back in, I'd be doing negative 6 plus 6 times negative 6 plus 2 equals 0. Well, what is negative 6 plus 6? 0. So I'm going to be doing 0 times something. Will that equal 0? Well, what's 0 times anything? 0. You notice, it doesn't even matter what that is. No matter what it is, 0 times that will equal 0. Now, in this particular case, it would happen to be -4, but that doesn't really matter. All we care about is that since they're multiplying by each other, 0 times anything gives us 0. And because of that fact, that now allows us to solve the equations without having to make the graph first, thereby saving ourselves quite a bit of work along the way. So we're now going to solve these two, but thankfully we don't need to make a graph for them. All right, so for this first one here, we want to solve it without having to make the whole graph. So based on what we saw in that last problem, if it was factored, we could go to the answer very quickly. So that means that in this problem, I want to factor it. Now, thankfully, this one's actually a fairly easy factor as such problems go, because it's just an x squared. There's no number in front of the x squared to complicate things. So we don't even need to worry about like doing a times c or anything like that. We can go straight to saying what two numbers add to the middle number and multiply to the last number. Well, in this case, my middle number is 1 because it's just plus x, so that's plus 1x. And I'm multiplying to -56. So what two numbers add to 1 and multiply to a -56? Yep, there is an 8 and a 7. Which one's going to be the positive? Well, I'm adding to a positive, you notice, which means I need to have more positives than negatives. So the 8 then, yes, is the positive. All right, I now have the factored form. From here, remember what we saw with that last one again. The solutions were the numbers that I could plug in for x that would make that equal 0. So what plus 8 equals 0? -8. So then -8 is a solution here. Now, if you can't just look at it and know, a lot of these you will just look at and know. But if you can't, really what we just did there is we said x plus 8 equals 0, and we solved that little equation. That's why x equals -8. All right, what about here? What could I plug in for x in that parentheses that would make that equal 0?
7.
Yep, 7. And so those are our two solutions. X equals a -8 and a positive 7. A lot easier than making the graph, right?
Yeah.
At least I hope it is. So with this idea in mind, go ahead and solve that second one now. And we can be thankful we don't need to graph it, because that would be a big graph. All right, so over the second one, we say what two numbers add to -57, multiply to 110. You should get -2 and -55. Again, order doesn't matter with these. If you wrote -55 and then the -2, that's fine. But remember, this is not our final answer. I still need to look at each of those two parentheses and say what would make it equal 0. So what minus 2 would equal 0? 2. And what minus 55 would equal 0? 55. Those are our two solutions. One thing that people start trying to do, I will say, there is a shortcut that some people try where they're like, oh, okay, I'm just going to jump straight from here to here. I don't want to write out that factored form because it's the same question. What adds to this and multiplies to this? But people who do that, about half the time, they forget to flip the signs. And they get them wrong. So you will hear me say to always write the factored form. All right, so now we're going to be solving these last two. And you'll notice that what makes these different is that they are not set equal to 0. Well, we can still deal with it, though. Because the first inclination that a lot of people will have when doing this is that they will try to factor this. But let's say we do factor it. Let's say we go through that and actually factor that into two sets of parentheses. What could I plug in to that parenthesis that would make the whole thing equal 11? It doesn't quite work that way, right? If it's equal to 0, then I can say, what can I plug in that makes it equal 0? Because 0 times anything is 0. That doesn't work with 11, right? There's no magic rule where anything times this is 11. And so because of that, we really do need the right side to equal 0, not 11. So first step, move the 11 to the other side. So the very first thing I'm going to do, subtract 11 from both sides. Notice you then have our quadratic set equal to 0. Now you can solve it like what we were doing on the last set. And so we look to factor it. What adds to 9 multiplies to 14. You should get 7 and 2. You notice that as I'm writing this down, I continue to write that it equals 0. That way we know it's going to work. And so then I look at each of the parentheses and I say what plus 7 equals 0 and what plus 2 equals 0. And we get x equals -7 and -2. All right, and then we go on to the last problem here. And the last problem, once again, it is not equal to 0. But we really need it to be equal to 0. Now, a little bit of plotting and scheming here can be very useful. I will tell you, the first thing I do when I look at these types of problems where I got to move stuff side to side is I make sure that my x squared term is going to be positive. Because if we end up with something that's got like a negative x squared, in order to deal with that, I have to like factor out the negative and some stuff like that. It just makes life a little bit more challenging than it otherwise would need to be. So, I keep my x squared term positive, which means in this case, I want to move everything to the right side. That means I'm moving the 15x. So, in order to move the 15x, I'm going to subtract it from both sides. So, minus 15x minus 15x. Remember to write the x with it. Every now and then I see people who write just minus 15. They're like, yeah, but I know what it means. But then this is going to be a problem for them because they're going to think that's a negative 115, and it's not. Because when I subtract that 15x, I have to be able to subtract it from a like term. Yes, I do get a 0 on the left, but can I do x squared minus 15x? Can I combine those two? Does that equal like, let's see here, I've seen people say negative 14x. Does that equal that? No, it doesn't. Because this is an x squared and this is an x. Those are not like terms. So the x squared, it can't be affected by the 15x. So it's got to stay in x squared. Is the 100 affected by the 15x? No. Because again, it's not a like term. So what do I do with the 15x? I just kind of put it in order and just sits in there with the other terms. But that's okay in this case because that makes it into a nice little quadratic and standard form that we then can look to factor and solve from there. So factor it, solve it. Let's finish this one out. And so we look for two numbers that add to negative 15 and multiply to a negative 100. That's going to be a negative 20 and a positive 5. And then once we get the factor form, then it's hopefully easy to solve from there because we're just saying what minus 20 equals 0, or in other words, x minus 20 equals 0, and I'm solving that equation. Even if you just look at it and know what the answer is, you do need to remember that this is really what's going on in the background here when we say what minus 20 equals 0. Otherwise, the more complicated versions are going to seem way more complicated instead of just one extra step harder. And then we do the same thing with the x plus 5 equals 0, so x also equals negative 5. So x equals 20, negative 5 on this one, and we're done.